Okay. So what is the next one? A motor car of mass. Mass is given to us. How much is it? 1200 kg.
वैसे लगा दूंगा जैसे
हाँ, लगा दीजिए. It is moving in a straight line. Uniform velocity is 90 kilometers per hour. Now what should you do? 90 kilometers per hour. Underline 90 kilometers per hour. Convert it into meters per second. Okay. Then velocity is slowed down to 18 kilometers. So 90 is what? Initial. It is slowing down. That becomes the final. Okay. And time they have given us 4 seconds. Calculate the acceleration. You know the acceleration, how will you find out? Same formula. A is equal to v minus u upon t over over. So even initial velocity, final velocity also should be in meters per second. Use these values. You put t, you will get a. Then calculate the acceleration and the change in momentum. Change in momentum.
Like mass into velocity. Initial velocity, so initial moment.
Yes. So
V equals
P2 minus P1. P2 is V. Okay. This is the initial velocity, final velocity. So that will be the change in momentum. Okay. And also calculate the magnitude of the force. So if you want force, you know the mass, you know the acceleration, and therefore you can calculate force. Is that okay? Can you do it for homework? Yeah? Okay then. Put a tick mark there. What's your next chapter? You want me to start?
exercise.
Which one?
Yes.
We have done most of it. What is the next one? Gravitation.
Yeah.
That's also a very interesting chapter. Very, very interesting.
This side is directly proportional.
Yeah, directly proportional. The force directly proportional to acceleration. Acceleration, the more the force, the more is the acceleration. Exactly. That's directly proportional. Okay, now let's look at the other exercises which are there. First one is, second we are finished. Third one, look at the third question. What's the third one? Why is it advised?
Why is it advised to tie any luggage kept on roof of bus on the road?
Once again, you people are not there. Arnie, do you remember what is happening? What we spoke about? You have finished this part. See, this is the bus. Okay? You recall? I
Yes,
know, okay, that was. Okay, so this is the bus. Okay? Bus is going. Think of inertia.
And the cardboard and the point.
Says it's moving, both of them are moving. Suppose it is taking a turn. The bus is taking a turn, but this object, the luggage, will not know. It tends to remain in the same direction, so
Yeah.
it tends to follow. So that is why we have to say inertia of motions of three types. Suppose this person is traveling. This is a bus, passenger sitting. Okay. Let's say the bus suddenly starts. What happens to the passenger?
We tend to move back.
झटका है, वो तो है, लेकिन is it forward झटका, पीछे झटका? Backward. Let's see what is happening. Both of them are there. Suddenly this moves in the forward direction. It is moving in the forward direction. So क्या होगा?
Backward.
Okay. Now let us say both of them are moving in the same direction. Both of them are moving. Suddenly the bus stops because there's the driver has a line. So what happens to the passenger? He still has a motion. He falls in the forward direction. Because the body is in motion, it continues to be in motion. Therefore, the passenger has got a forward motion. Is that okay? I want you both to read the inertia once again.
inertia and mass.
Wait, I'll tell you the passage.
91.
No, my. Yeah, you have a column like this. Next to it has said safety belts are worn to prevent such accidents. Certain experiences, do you have any passage like that?
Yes.
Certain experiences, did you get it? Which page is that? 90.
Yes.
How much?
90.
Mine is 116. Can you imagine how much they have cut from the original one? So much portion they have actually.
That's really sweet of them.
Yeah. Chalo, whatever. Certain experiences. Do you have that?
Now safety belts मिला, लेकिन certain experiences नहीं.
Show your book. हाँ, मैंने मोटा कार
हाँ, मैंने मोटर कार
यहाँ भी है ना, यहाँ भी है ना इसके पहले एक safety. Certain experiences. हाँ, चलो वहाँ से पढ़ो.
Certain experiences that we come across while traveling in a motor car can be explained on the basis of the law of inertia. We tend to,
Underline law of inertia.
we tend to remain at rest with respect to the seat until the driver applies a braking force to stop the motor car. With the application of brakes, the car slows down, but our body tends to continue in the same state of motion because of its inertia. A sudden application of brakes may thus cause injury to us by impact or collision with the panels in front. Safety belts are worn to prevent such accidents.
Put a Q there. Question.
Give reason.
Or give reason. Okay, what happens? Why is it that we should have? So you have to explain in terms of inertia. The body which is in motion tends to be in motion. So in this particular case, the body and the passengers both are them moving. When sudden brakes are applied, the bus stops, but the passenger still tends to continue his forward motion. Therefore, he needs to have a seat belt to prevent injuries.
Safety belts exert a force on our body to make the forward motion slower. An opposite experience is encountered when we are standing in a bus and the bus begins to move suddenly. Now we tend to fall backwards.
Underline that. We tend to fall backwards. Put another question.
This is because the sudden start of the bus brings motion to the bus as well as to our feet in contact with the floor of the bus. But the rest of our body opposes this motion because of its inertia.
So what should we explain it by? Because of inertia. Someone write down this answer. Right. Number 3, na?
Why is it a
Number 3. Write down the question.
Question.
How will you know what is the answer?
Number.
But every time you will, when you are reading from the book, you will refer to the text. Oh, what? At least you write down some keywords, no? If you don't, how long does it take for you to write the question?
It takes time.
Come on, tell. Don't be so lazy. How will you start the answer?
It is advised to tie a rope.
It is based on the first law.
Yes, that should be the first one. Based on law of inertia. The body, come on, write down. It is based on the first law of motion or law of inertia. So what does it say? What does the law of inertia say? A body at rest tends to remain at rest. A body in motion continues to be in motion.
The word inertia should be mentioned.
Mention. Then there are two cases. When sudden brakes are applied, that is the first case, and the second case is when the bus suddenly starts moving. In both the cases, what will happen? What will you say? When the moving bus suddenly stops, क्या होगा?
Means it will tend to keep.
The luggage will still continue to be in motion in the forward direction, and it will fall off if it is not tight. Tika, Nagi, what did you write?
None.
Ah,
None. There are 8 seconds.
in the second step. If the bus starts suddenly, the bus is set in motion, but the luggage, object or the luggage tends to fall back.
If the bus starts suddenly,
The bus, see here, imagine, bus is starting suddenly. Initially क्या है, the luggage is also at rest,
yeah,
bus is also at rest.
yes.
लेकिन अभी ये this will start,
हाँ,
तो ये इसको क्या होगा, it will fall behind. So the luggage will fall behind
and it will
because it tends to remain in a state of rest. Hence, to prevent etc. Control your state. Therefore, it should be tied. Okay? Is that okay? Good? There's this graph wala sum.
हाँ,
So what is it? It's a velocity and time graph. So velocity and time. Time is given in seconds.
Yes.
Velocity is given in meters per second.
No, centimeter.
They are given in
हाँ, velocity
centimeters.
centimeter.
ठीक है. Then what are we saying? The velocity time graph of a body of mass is 20 grams. Mass is given in grams. Do you understand which scale are we using?
We have to do a converting figure.
No need. It is CGS. CGS. C is what? It is in centimeter. G is grams. So it is anyway in CGS. If one is in MKS and the other one is in CGS, then you have to convert. If everything is in CGS, there's no need. Then what should we do?
So this is the standard units.
No, these are not. MKS is the standard unit.
Yeah.
CGS units. So now what is happening? It's coming like this. Velocity is coming down after the time. So what is the initial velocity? Time, if time is 0, what is the initial velocity here?
20.
Is it starting with 20 then? Okay, so initial velocity is 20 meters per second. After what time? What is the time from here to here?
10 seconds.
Time is 10 seconds. V0. After 10 seconds, what has happened to V? It has come to 0 meters per second. Yeah. Using this U, V, T, what can we find?
Acceleration.
You can find the acceleration. Is it positive acceleration or negative acceleration? Negative. because कम होती जा रहा है, velocity कम हो रहा है तो अच्छा. So using this information, what are they saying? How much force does the kidney exert on the ball to bring it to a rest? Am I doing? So information is given to you in the form of graph.
minus 14.
Good. Find out A.
No, minus 40 or 14. Minus 14.
14.
मुझे 14 बोला.
मैंने 14 बोला.
Okay, very good, correct.
चलो चलो. V is 0, U is 20, and time is 10.
Minus 40.
What?
Minus 40.
What did you find out?
10.
Force also you have found out? Okay, now you find out. Let me tell you the units here. What is it? Is it plus, minus? What is A? How much is A?
Minus 2.
Minus 2 centimeters.
Minus 2.
Centimeters second square.
Yes, per second. It is in centimeter, remember. Now let us see what is that. Have they given any mass?
20.
Yes, then mass is in 20 grams. So for you to do that, okay, if you want to find it out in terms of Newton, then it should be in meters and the mass should be in kilograms. If you want to find out F, which is mass into acceleration, and if you want the answer to be in Newton, then mass is going to be in kg and acceleration will be in meters per second square. So acceleration here, minus 2, convert it into meters per second square. How much is it? How will you convert?
0.00.
Divided by. So 2 divided by 100. Hello. 0.02 meters per second square. Isn't it? 100 centimeters is 1 meter. So I have now 2 centimeters is equal to x meters. So what will I say? It is 2 divided by 100, which is equal to 0.02 meters per second square in this particular case. So it is 0 minus 0.02 meters per second square. Okay. Next, what do we have there? They have given you mass. Mass is how much? 20 grams. How will you convert it into kg?
1000.
Divided by 1000. So 20 upon 1000. That is going to convert it. That is 2 divided by 100. So 0.023. So 0.02 kg. Then now you are going to find out force. Substitute mass, substitute the acceleration and give me the answer in Newton.
0.00.
Cut. Do that.
0.
0.04.
0.30 and 4.
Yeah. There are 4 decimal points. No, 1, 2, 3, 4. So you have to account for 4 decimal points. So 0.0004. and then the answer will be in Newton. Did you see that? So this is a very interesting example because sometimes the information is provided to you only in the form of a graph. So how will you interpret the graph? Take down the information given to you. All these things we have taken down from the graph itself. Did you understand, Gargi? So using the information which is given in the graph, we are going to work out. Samjha? Okay. चलो हो गया. Then the rest of it is, these are all for momentum. We don't have all this. Whatever, see, because another 2 pages is all full of momentum here. You have question number 8. What is 8?
One automobile vehicle with a mass of 1500.
Have you done that?
No.
Do that. Have you written any tests so far?
Yes, physics.
Likha? Motions. Motion first. First one. Okay. What about chemistry you've written?
No, it is in not yet.
So what is it? Take down the information, the same thing. I want you to first write down, try to understand what is given to us, what we have to find. Read the sum carefully. Which one is it? Sum number? 8. Largi, tell me now. Question number 8. Read it out, understand, and then we'll fill up the information. What are those numbers? What is the 1500?
Mass.
That is it. Yes. Then 1.7 is what? हाँ. तो क्या लिखोगे? Mass is given. How much is that?
1.7.
How will you write negative acceleration?
Minus.
Yes. Okay. Acceleration. And what is the number which they have given? 1.7. It's a negative acceleration. Understood? So how will you write negative acceleration is number which has 0 negative acceleration. Correct? So we know M, we know A. What should we find? Force. What happened for that? Force. Correct. That's it. But answer will be what? Is it positive or negative? It will be negative. So what is that negative force? That is your braking force, or it is the frictional force. Check.
Minus 250. And the units after that.
Force. We are finding out force.
This is what the
The minus 250. What will be the unit of force? Newton. Newton's law, no? All this, that chapter is Newton's law. So obviously we have to honor the scientist. So force is Newton.
Do you like exercise? Do you like Newton?
You must be thankful. You must be thankful for Newton because of him and so many ideas that he has been able to formulate. You are living a very comfortable life right now.
But whatever coconut had fallen itself and actually,
But
whatever coconut had fallen itself nothing.
you are lucky. He didn't actually fall on his head or anything of that sort.
Why?
Whatever it is, it keeps happening all the time and nobody even bothered. But because of him, because of his inquisitive nature, many of the scientists who have discovered few things, it's quite accidentally. But because of their curiosity, they were able to, find out much more. Oh yeah, next one a question they could get.
What is the moment of field of mass and moving with a velocity v?
B option. B.
V is equal to m into v. So they have given you different options. It is your MCQ. Okay. Next one, what do we have?
Using a horizontal force of 200 Newton, we intend to move a wooden tablet across the floor at a constant velocity. What is the frictional force that will be exerted on the tablet?
क्या है? ये हो गया तुम्हारा कैबिनेट. Always think. Imagine. You're imagining. ये है. So what are we doing now? We intend to push it with a force of 200.
200 Newton.
तो क्या हो रहा है? What is the frictional force? यहाँ frictional force है.
Same.
And look, आपने बोला frictional force is equal to force.
Which law? Which law?
Third.
हो गया? Action force by the person on the cabinet. The action force by the
cabinet.
on the person. Because of it, they're acting on two separate things. But the what will be the value? Will it be positive or negative? Opposite directions. So it will be minus 200. समझा? लिखो. Write down this in your notebook. So the frictional force will be minus 200. I've given you a few things to do for homework. Do them.
Right now.
No, homework. Homework.
You're like, do that.
Do that. I'm reminding you. Okay, I think we are done with this chapter. Bolo.
Question number 4.
Bolo.
A batsman hits a cricket ball which then rolls upon a level ground. That question.
Yeah. Read it.
After covering a short distance, the ball comes to rest. The ball explodes because the bat.
Third one, no? Option 4. आप fourth question का third option होगा ना?
Oh, अच्छा.
वो rest हुआ because there is a force on the ball opposite the condition. Maybe it will be third. See.
Okay.
See.
Done. So we can, because it's a 1.5 hour class, so I don't want to just waste our time doing nothing, right? So I'll just start with the next chapter, which happens to be gravitation. So we'll start with gravitation, chapter of gravitation.
No need to write.
क्या gravitation के बारे में? Okay, we are just waiting for the other two also. I'll just give you a small idea because now we have so much of time. Okay. What can you know about gravitation? What do you know about gravitation? It's a force. Very good.
Force.
Very good. So did you realize that all these chapters are all interlinked? पहले हमने motion के बारे में पढ़ा, then we know about force, then we have learned about all the three laws.
Non-contact.
Yeah, it's a non-contact force, correct? Gravitational force is a non-contact force. Where is it present? On the earth. Okay, fine, very good.
Yeah.
Is it present anywhere else?
On every celestial object, every celestial,
Very good.
because
Okay.
everything has
Not
gravitation.
around the sun.
Okay, all the objects, all the planets which are moving around the sun, it is definitely having some kind of a gravitational force. Okay, and it's because of this gravitational force that we have got various objects which is moving. Is there anything that's moving around the earth?
Moon.
That's your
And
natural
the
satellite.
satellite.
Okay, so the moon is also governed by the gravitation, and that's how it is moving around the earth. Okay. For us to understand, so in which shape is it moving?
Oval.
Roughly, you can just say roughly it is a circular one. So we come back once again to our circular motion. So basically, what is your circular motion? You recall the first chapter that we talked about?
In the end.
Suppose a body is starting from A and it is coming back to A. There are two things. Can I find out distance? Or
The
how?
circumference is equal.
Correct. The circumference of the circle itself will be the distance. What is displacement? Zero. Because starting is here and the ending is also here. So the displacement is zero. Now we are talking about the force. Okay. Suppose a person here has tied a string to a stone and he is moving it around. So the object is going in a circular approach. Yeah, you're coming right. What happens if the string breaks? It's moving in a particular direction. So the stone is coming here, the stone is coming here, etc. etc. Which direction is it going? It's going in the tangential direction. So what is tangent?
Parallel.
Perpendicular.
Right angle.
It is right angle to the direction of the force. So the force is towards the center and the direction of the object is in the tangential direction. What is tangent?
Perpendicular.
Yes. Okay. So when it comes here, what is happening? Suppose this is the radius and we draw a line there. So this is the tangent because this angle is 90 degrees. So at every particular point of time, you see that the direction will keep on moving, though the speed remains the same. Go.
I mean, is there a tangent and it's going to move? I have other issues.
What?
Tangent.
Tangent can be anything. For example, if I say it's a normal force, what is this angle?
But
Right
in
angle.
different shapes.
For different shape, at any particular point of time, if you are drawing a normal, when you say it is a normal force, it means that at any point it is at 90 degrees, it is a normal force. So tangential shape, and the word tangent is specific to any particular point on the circumference of the circle. Is that okay? So here what do we say? It is uniform speed. But what is happening to direction? Yes, the direction is changing. Now what is happening to velocity? Therefore, what is happening to velocity? Will it remain the same?
No.
Think about two things. Velocity depends upon two things. First chapter.
This, displacement,
Distance and speed. So
Not distance.
displacement
distance.
upon
Not upon. The velocity depends upon what? एक तो उसका magnitude है and the one is direction. So because the direction is changing, the velocity is also changing.
There will be three cases.
Yes.
Speed change, direction change, or both.
Yes, correct. So in this particular case, what is happening is because it is having a variable velocity, which you can say that it has got an accelerated motion. Okay, so the motion which is moving, anything, any body which is moving in a circular shape has got an accelerated motion. So basically, what happens is now taking this idea, whatever we have learned in the last two chapters, we are going to be talking a lot about universal law of gravitation. Okay, it is an extension of this idea that we will talk about Newton's laws, the universal law of gravitation, what is free fall. Have you seen the video of really free fall? Feather and a stone which is being drawn? No? I'll show you next time. It's a wonderful video and I want everybody to see that. Everybody come next time. Then we talk about mass and weight. Okay. Nice chapters. So before I start, I want you to go to the first chapter and see this part, uniform circular motion. The first chapter, motion. Get it? Now this paragraph, the one that I asked you to underline. If an athlete moves, read.
If actually moves with a velocity of constant magnitude along a circular path, the only change in this velocity is due to the change in the direction of motion. The motion of the athlete moving around a circular path is therefore an example of accelerated motion.
Underline. Did you underline? This is
Underline.
like yes. She was absolutely.
We know that the circumference of a circle of radius r is given by 2 pi r. If the athlete takes 15 seconds to go around once around the circular path of radius r, the speed v is given by v equals to 2 pi r upon t.
Okay. Okay, is that okay? So we are using this idea, which we have already learned in the first one, coming back again to the gravitation. So you should always remember that a body which is moving in a circular path has got accelerated motion. Okay, I want you to leave 2 pages for doing your homework. 2 pages should be fine because there was 4 sums or something I've given you. So teach her to go through it and write the next one. Next topic will start off with gravitation. You did not go during the recess, you should have gone. Now, why do we give you 15 minutes time? Next time, please don't make this mistake. Go on. Please utilize the 15 minutes. Okay?
Yes, ma'am.
Right. Waste of the stuff that will follow. चलो देखो gravitation.
you know Bang, right?
Your brother?
You
Of course I know him. Where he's got his this thing, admission?
he has taken integrated and the classes he has taken for Alan.
Alan.
He has taken science.
So first I want you to underline and write down something about uniform circular motion for you to think always, right? Uniform circular motion. So you write, when a body moves in a circular path with uniform speed, then the current is generated. So when are your school starting now? 10th? Or
Second.
Second.
हाँ बहुत
Then
yeah.
10th will be for state boards and 4th
Yeah,
will be for
exactly.
ICC.
क्या 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 बोला हमारे सेकंड चल रही है
ICC का तो है.
फोर्थ चल रही है ओ
Fourth or second.
What is it for you?
Fourth or second.
You still not yet announced.
ICC है ना तेरी.
Second, na?
Wow, मेरा ICSE है, मुझे यहाँ पर
CBSE है तो सेकंड का होगा एग्जाम ईयर
Chalo. Come on, write down. Uniform circular motion. Because I want you to
the
remember.
body is moving in a circular path
Yeah,
with uniform speed
yeah. Hurry up, we are all waiting for you. Madam. Just tell that starting word. So that it gets. When a body, come on.
when a body is moving in the circular path
With uniform speed.
is
Is what?
क्यों नहीं हो सकता
When it is moving in a circular path with a constant speed, the only change in velocity, correct? Uniform speed, the only change in the velocity is due to the change
Change of direction.
in the direction of motion. Okay, in bracket use this word tangent. You can express it in your own words. It is tangential to the path. Also that way. Okay. Next point you should write. Therefore, the motion of the particle you can write, you can use the word object. Therefore, the motion of the object is an example of accelerated motion. Is that okay? So now we come back again to whatever we have been discussing. Suppose we are talking about the earth and we are talking about the motion of the moon, right? So it is moving because of some kind of a force. And what is that force? It is what is known as the centripetal force. Right? Centripetal.
And then what is centrifugal?
It's opposite to that. The force is getting thrown out. It's actually a virtual force. It's not an actual force. So a centripetal force. Now can we actually imagine what is centripetal force? Same thing as you're holding a thread and you're tying a stone. The person who is moving around, so he's the one who is actually providing the force. And this force is the one which is centered towards the center. So it is a center seeking force. So the moment we say it is a centripetal force, it means that it is a center seeking force. Okay? Similarly, obviously, this part of it you have already realized that it is an accelerated motion. Okay? So we are talking about all the bodies which are present on the universe. So initially that part was only the force which is present and it is a gravitational force. But much later on Newton was the one who was able to prove that such type of forces are existing not only on the surface of the earth but it is present all over. Okay? So it is the universal forces which are present all over. And what is about this force? This force is directly proportional to the distance between any two objects. Have you followed? And also it depends upon the masses of the two objects. So depending upon them, we are going to be talking about one simple equation. Before we go on to that, just read the first one. Want to read? Read first paragraph.
We know
उसके ऊपर वाला. In previous chapters, we have learned.
we have learned about the motion of objects and force as the cause of motion. We have learned that a force is needed to change the speed or the direction of motion of an object. We always observe that an object dropped from a height falls towards this earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, there must be some force acting on the objects. The planets and the moon, Isaac Newton could grasp that the same force is responsible for all these. This force is called the gravitational force.
So basically, we are going to be talking about gravitational
Yes.
force. Underline. Even though the topic is given only as gravitation,
Yes.
but what is it? It's nothing but a force. It's a force of attraction.
In this chapter, we shall learn about gravitation and the universal law of gravitation. We shall discuss the motion of objects under the influence of gravitational force on the earth. We shall study how the weight of a body varies from place to place. We shall also discuss the conditions for objects to float in liquids.
Okay, so that is all that we are going to study in this particular chapter. Not only about gravitational force, universal law of gravitation, universal constant, what is the difference between weight and mass, okay, and also about flotation. So all these concepts will be. That part of it, I think they have kicked off actually. Show me a book. Flotation and all that is not there, no?
No, that.
Then they must have deleted once again. Mass and weight is there.
Yes, mass.
Objects
Yeah, it's
float
there.
or sink
It's thrust and pressure is there. Pressure is fluid system. Archimedes principle. All that is interesting. Okay, Vidya? Gravitation.
Gravitation. We know that the moon goes around the earth. An object when thrown upwards reaches a certain height and then fall downwards. It is said that when Newton was sitting under a tree, an apple fell on him.
Not a coconut, huh?
I'm just
And not on him. Maybe somewhere around him. But definitely it was not.
Yeah.
Nothing happened to Newton.
the
World
force.
would have been a different place if something had happened to Newton. Let me tell you that. If Newton had not discovered and he had not put forward all these things, it would have been an entirely different world.
The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So it must attracted by the earth. But we do not really see the moon falling towards the earth.
Isn't it? There is a force which is present. The force is pulling the moon. Why is it that the moon is not falling towards the earth?
because moon has its own gravitation, that is it's like
It has its base. It has its, yeah.
Because of the moon in high tides and low tides happening.
Yes. We are getting the tidal effects because of the gravitational effect of the moon. We have the spring tides and the neap tides.
Yeah.
Yes.
Okay, so when the sun, the moon, and the earth are in one line, so what is the earth feeling? It is the combined gravitational force of not only the sun and the moon. So obviously you're having spin tides on both the sides. So that's when you get very high tides. But when it moves, when the moon, you are understanding what I'm saying, right? This is the earth, right? The moon is here, and of course this is the sun. So when the sun and the moon, they're all in the same line, we get very high tides here. But when this moon comes here, then it is a neap tide. It's spring tide and a neap tide. So it is because of the gravitational force.
Should I read the activity?
This we have done it so many times. I have explained to you
Yeah,
this
so no.
person swinging, etc. etc. Chalo, you read on card. Before the
Oh,
thread.
because part.
Sorry, sorry.
From before.
Yeah, before the
Before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. The change
What is important here? Please listen very carefully. The stone moves in a circular path
Yes.
with a certain speed, that is uniform speed. It is changing
Circular
direction.
path is uniform.
So it is changing direction at every point. That is something that you should please underline and remember. Okay, next line also underline.
The change in direction involves change in velocity or acceleration.
Underline. Why? Why? Just now I made you write.
Because for change of velocity, there should be the change of direction or the change of magnitude or both. So,
Here the speed is constant, only direction is changing. So it's obviously very good.
the force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called the centripetal, meaning a center-seeking force.
Underline centripetal force or a center seeking force, because the force is centered towards the middle, the center of the earth.
In the absence of this force, the stone flies off along a straight line. This straight line will be a tangent to the circular path.
Underline. What is the key word?
Tangent.
They have also given you what is the tangent.
The motion of the room around the earth is due to the centripetal force.
Underline. Centripetal force.
The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple.
Okay,
Why?
let's listen. Let's try to understand the question. Moon, the earth is there, apple is falling on the earth. And we said that such type of gravitational forces are present all over. Why is it that the apple is not attracting the earth? Or why is it that the moon not attracting the earth? Why is it that we are not able to see this motion?
Smaller mass means less gravity.
So basically, we are talking in terms of masses. Greater the mass of the body, obviously the force is going to be more.
And
Okay?
Israel also done like that Mangaland one with this concept. That means they for one day the satellite will revolve around the earth, and then at some point they will burst some gases, and then it will go like in the tangential direction
This is the sun.
before 6 months to reach Mars.
To save fuel, and this is Earth and this is Mars. So you go force around here, and then it will leave it. So it will go up here. Then again over here. That way. Right.
So when you are talking about, that is one of the best ways to consume fuel. And see, if you are comparing the launch of a rocket by our Indian ones and compared to the others, where they are using a lot of propellant in order to make it as a straight line. So this way, what is happening is you are conserving actually some amount of fuel, because every time it is moving around, and then you are giving a thrust in order to move it into a higher orbit, and that is what it is happening. Okay. Then, according to the third law of motion,
According to the third law of motion, the apple does attract the earth.
is it true?
Yes,
No, if there is a force of attraction, there should also be one. Okay, but we don't actually see. Why? The answer is given.
But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. The mass of an apple is
Negligibly small.
negligibly small compared to that of Earth. So we do not see the Earth moving towards the apple. Extend the same argument for why the Earth does not move towards the moon. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. From the above facts, Newton concluded that not only does the Earth attract an apple and the moon, but all objects in the universe attract each other. This force of attraction between objects is called the gravitation.
Well, there's a lot of information in this. Have you followed? No.
Yes.
F is equal to mass into acceleration. Correct? So we are saying that force and directly proportional to mass and obviously acceleration. Okay? But he was the one who said that we are talking about the forces which are present between the two masses. Suppose you are considering this as mass 1, and let us say we are considering another mass which is mass 2. Okay, it can be any mass. He said that the force which is existing between these two, what is it? It is the force which is existing between these two masses is what is known as a gravitational force. So F is nothing but the gravitational force which is directly proportional to the masses of the two objects. Okay? So depends upon M1 and M2. So if the mass is more, then obviously the force is also more. Second thing he also said was that it also depends upon the distance here.
Newton.
What happens if the two objects are very far away? What will happen to the force? It will be more or less?
Less.
It will definitely be less. Just think about two magnets. If the magnets are very close to each other, magnetic force will be more. But if the two magnets are moving very far away, what happens to the force? Force spread will be very less. So this force is also inversely proportional to the distance, this d. D is nothing but the distance between the two objects. He also
What
said
is
it is
that?
the square of the distance.
And that is
Which one? This one?
distance S.
That is distance.
So what is this D?
D is just to tell you that it's not moving, we're just measuring the distance between the two objects. Okay? So when you are combining these two, what are we getting? F is directly proportional to M1 by M2 divided by D square. Are we okay or
No.
going up? What? Understood?
And
Yeah.
same as the means the force the sun attracts to the Pluto is very less. So that's why it is means it moves like this
Going
slanted elliptical orbit. Or like if it was a Mercury, means it will have more force.
Because the distance is less, obviously the force vector is very less. Okay? So the third one is we are combining these two. So when you combine, what happens is F is directly proportional. Look at the numerator. On the numerator, we have got M1 and M2, and in the denominator, we have got D square. Did you follow it? Look at the diagram which we have drawn. A and B is given to us. Look at the diagram. Instead
What
of
is
using
G?
what G? That I have not yet done. I've come only till here. Have you followed here?
No.
Instead of you writing as A and B, I have just indicated as masses. You can write M1 and M2. You can also write small m and big M. Okay, so here we can also say it is small m, and here we can say it is capital M, just to show that the mass is slightly bigger. Okay, so now this is directly proportional to Z. So the next level is when we want to write down the final equation, F is equal to capital G. So capital G is a constant. It is what is known as a gravitational constant. And then it comes as M, capital M, small m divided by D square, where D happens to be the distance between the two objects.
So now, like that. D square, why?
Why D square?
Why not D?
Why? Because it is with help of experiments, they have found out that it is not only the distance, but it is the square of the distance that is taken into consideration for g to remain a constant.
So if there's only one meter, G is not constant.
No, definitely it will not work because with the help of experiment. So for someone to come up with a formula like this, they have to keep on experimenting and finding out. Okay, and it works only if you are taking t square as the distance between the two objects. Is that okay? Did you understand now? Followed? Let's read that part.
Universal law of gravitation. Every object in the universe attracts every other object with a force which is proportional
Which is that which is proportional.
proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stop. This is a very important statement. And every object in the universe attracts every object, okay, in the universe with a force which is proportional to product of their masses. By product because it is m times n. It is not the sum of, it's a product of, and it is inversely proportional to the square of the distance between them. Understood? Did you underline? That is underline. That is your gravitation. Okay, that is your universal law of gravitation. Whatever.
The force is along the line joining the centers of two objects. Let two objects A and B
Have
of
they written
masses-
as d square? Is the formula written properly? Or it is written as d2?
No, square.
It has to be d square.
Yes.
If it is written as d2, please make a mistake. Make a correction.
Let two objects A and B of masses M and capital M and small m lie at a distance d from each other as shown in figure 9.2. Let the force of attraction between two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses.
Underline product of their masses.
Yes.
Directly proportional to the product. That means m times n. M multiplied by n.
That is force directly proportional to capital M into small m. And the force between two objects is inversely proportional to the square of the distance between them.
Underline this word, inversely proportional. Inversely means what? Your d square will come in the denominator. Okay. What does it mean? If the distance is increasing, the force is decreasing. Okay, this is the square of the distance, not only d. Okay?
That is force directly proportional to 1
Mn.
upon d square.
Mark I give it. Yeah.
Mark on the break the
Yeah. Okay, यहाँ तक. Okay, G is equal directly proportional to M by D square. And therefore, the capital G that we are talking about is a constant. It's a constant value. That's why it's called as a gravitational constant.
That's so much more in physics.
Ooh,
Huh?
what?
There's so much more.
Yeah, going deeper and deeper, obviously. And see how wonderfully one chapter is just getting, we are using all those topics and all those ideas. In fact, Newton has used, it was not basically his own idea. He has used concepts of Galileo. They've given you a lot about Copernicus, Kepler, Galileo. So they have done a lot of idea regarding the motion of the planets and all. And quite a lot of calculations are also there. Yes, here they have written. As a keystone of the scientific revolution, Newton's work combined the contributions of Copernicus, Kepler, Galileo, and others. This is given. ये वाला है?
हाँ,
हाँ.
90.
अच्छा और है
यार, अरे ग्रेविटेशन में है.
मामा, gravitation में नहीं है।
you don't know
वो आर्किमिडीज के लिए।
अरे नहीं रे. This is where we find which is here.
नहीं है।
हाँ नहीं है मैम, नहीं है।
It's not there.
नो,
So this part again.
सिर्फ एक ही है ना।
This will automatically be this. Then we are here they have given something. This is about Galileo. This is about
हाँ,
Galileo.
अबे यार
अच्छा ना कम हो गया
Of course, nothing was asked here, just for information to what he has done here. No questions will be asked of him, just for curiosity. It's more like how they have actually studied. Okay. Are we good to here? So what is this capital G?
constant
It is a constant. Okay, so it is known as a gravitational constant. Why is it a constant? Not only will this number will remain the same between two bodies sitting next to each other or in between any one body and the other body which is in universe. Okay, so that value is always going to be a constant. Samjha? Here till now. Just one or two lines, you read now.
Written.
No, these lines, two, three lines at least. Okay. What have you written? Only that first part about circular motion.
Yeah.
Not at all. Okay. Then you write down heading as universal law of gravitation. क्या बोला? Draw the diagram. Draw the diagram. Show that there are two objects having two different masses. Why are there two arrows? Did you notice that there are two arrows like that? क्यों बोलो?
only notice
the amount of gravitation.
It doesn't tell you what the amount. That arrows will show you what.
D this side, D this side, like this.
The D is the distance between the two. The arrow क्या बता रहा है? What are we talking about? Force. Isn't
हाँ,
it?
exactly. दोनों sides से force.
हाँ तो क्या हुआ? A is attracting B, B is also attracting A. So that is how the arrow is shown. A is the force of A on B, and if you put an arrow on this side, it is the force of B on A. So forces of both the bodies. Is that okay? We continue from here. Is there anything else that we can write if you see? I'm going to do that.
Which chat about physics
What about physics?
or what started.
We will find it amazing. In fact, even when we are doing our lessons in electricity, current electricity and all that, you come up in 10th standard. So it was just by chance that have you heard of electromagnetism?
Yes. Yes.
So electromagnetism, that means when you're passing electricity, it develops a magnetic field. That was actually by chance that the scientists found it. And using this particular concept, we have developed motors, generators. You know, the production of electricity itself is based on that. So can you imagine? Will you say, "Ha, Jana was scientist for without electricity"? Can you imagine sitting like this?
And no electricity, no internet.
Forget about internet. At least your generation is with internet.
Yeah, in your time there was nothing.
No, nothing. There was absolutely no internet. Internet is a very recent phenomenon. And in a few years' time, maybe another 10 years or 20 years, there'll be something else and people will think, "अरे वो ज़माना था जिसमें internet था." Maybe you know you will be talking like that. Maybe the next generation will be thinking, ours will be already history
Yeah.
because things are moving so
I
fast.
think story someone's kitchen.
What are you like?
Wow, weird. Like
What?
Gen Zs are the most particular. They would be like in their 20s, they're gonna act like they're retired, and then like
Act like this as if they're going to be done.
retired, and then they'll have world news and all that. The research says.
Forget about it. That is it's a statement that which does not hold good for anything and for everywhere. It may be just a statement, that's all. Can you predict what is going to happen tomorrow? Yeah? And what's going to happen next minute? Did you know that your body was going to fall down? You can't predict anything. So that's it. Have you talked anything about natural phenomena?
Lightning.
No, I mean like we are talking about let us say polar regions.
No.
It's not raining.
अभी तो polar regions में क्या है? You have got a sheet of ice, but there is light there under the water. There's a sheet of ice.
Sometimes survival is hard for the aquatic level.
तो क्या हुआ? So they have adapted, no? So when we talk about science, it's not only physics, it's not only chemistry, it's not only biology. It's a combination of everything. Animals like, let us say, sea, polar bears, don't they survive? They're surviving.
Penguin,
Penguin. Why?
they're adapted.
There you go. Adaptation. They have to adapt for survival, otherwise they become extinct. How did they adapt?
Their body adapts.
How?
Means they have a thick layer of fat under the skin, and their skin fur is black. So because of reflection, we see light. Means its color is white, but their actual color is black.
Okay.
To conserve
Black and
energy
black.
because it
Absorb.
absorbs more energy,
And they're thick for
and they do hibernation.
Yes. They sleep for good about 6 to 7 months. In a year, when it is severe winters, they go for sleep. So these are adaptations. Different organisms, how they adapt themselves to different conditions. Now my question once again, suppose you're having a sheet of ice on a lake, what happens to the organisms which are present? Will they survive or will they die?
yes, the above layer will be only frozen, right?
Yes.
Not the below layer. They can swim.
So that itself is a condition. It's a phenomenon which is called as anomalous expansion of water. Okay. When ice is frozen, how is it that only one part of the ice is frozen and what happens to the bottom part? It's still water. Why is it that the entire water is not getting frozen? So that is what is known as anomalous
Because the
expansion.
first layer is getting the currency power.
Correct. So that itself acts as an insulator so that the outside temperature, even if it is -20, -25, these layers of water the egg
Will be
will
warm.
be at 4 degrees.
So they will be warm
Comparatively.
like an igloo.
Yes. And igloo also is comparatively much warmer if they are building it up with blocks of ice. It's actually acting as an insulator. Air is also an insulator, you know that?
Yes. It means it gets stuck in the means any cloth made up of wool. So
Why
that's
do we wear woolen clothing? Why do we wear half sweaters made of wool? Thick, and also because of the fiber, what he said was right. Because air gets trapped inside those fibers. And that itself provides an insulation. Good. We'll continue our next class next week.
Thank you, ma'am.
Thank you.
ma'am.
no.
We will attend that Saturday, na? Next Sunday. Next Saturday.
मैंने कैसे दी
नहीं वो आया ही नहीं you know
कल आया था।
उस दिन मतलब परसों आया था ना कल भी आया
अरे कल एसएससी का था ना।
हाँ कल ऐसे एंड वो आए मुझे ना उस टाइम पर इतनी बार से संडे को इधर लाइक एंड टेस्ट का टाइमिंग था 1 बजे।
वो हाँ मैं गाँव में था वो पूरा मतलब 3 मतलब क्या बोलते हैं 3 ये क्या बोलते हैं सीढ़ी तो पूरा का पूरा सीढ़ी जितना पानी भरा था।
भाई एंड लिटरली टेस्ट के लिए मैं और उषासी थे इतनी बारिश थी भाई मैं पूरा भीग के गई मैं।
मेरा सॉक्स भीग गया और इतना बरसात आ गया और
अच्छा ये बोलता है हाँ थैंक यू मैम